Four quick examples on using sigma notation to in the context of arithmetic series. Here's example 1. Evaluate the sum of the first 50 terms, this really means the first 50 terms from n1 to n50 of the arithmetic series that follows this rule, 3n minus 4. Okay, so when we do these, we're always going to make use of this formula here, the simpler of the two formula relating to arithmetic series. So what we're seeking to find at this stage is a value for n, a value for a and a value for l, and we are done. Now quite clearly the value of n is 50 because there's 50 terms in the series. The value of a is going to be found by substituting 1 into our rule, and the value of L is going to be found by substituting 50 into our rule. So let's note down what the values of N, A and L are first off. So quite clearly A is equal to substituting N equals 1 into our rule. We get 3 lots of 1 minus 4, and that's 3 minus 4, which equals negative 1. The value for L is found by substituting 50 into our rule. So it's 3 times 50 minus 4, and that's 150 minus 4, which is equal to 146. So the sum of our series of the first 50 terms, so we can write S50, therefore S50 equals n, we said was equal to 50, divided by 2. And then we simply substitute the values for A and L in there. So it's negative 1 plus 146, which is equal to 145. And by your calculator or otherwise, you are going to find that the answer is 3,625. Just squeaked it in. 3,625. Okay, so that's how we do a very basic example of sigma notation. Let's move to another example now. And there's nothing very different about this example, except you'll notice that there is a minus n going on there. And we've just got to be a little bit careful when negatives are involved, pretty well in any area of mathematics. Okay, so let's get cracking on this one. So again, we're going to use the formula Sn equals n over 2, A minus L. We can always use this formula for sigma notation problems. Now here, A is found by substituting 1 in place of n, so that's equal to 12 minus 1, which equals 11. And L, so we're finding 30 terms in this series, so the last term is found by substituting 30 in place of n, and we get 12 minus 30, which is equal to negative 18. Okay, now there's 30 terms in our series, so we know that n is equal to 30. Alright, substitute away, and here's what we get. So the sum of the first 30 terms is equal to 30 on 2, bracket, A we said was equal to 11, and L is equal to negative 18. Okay, so here we've got a plus, a minus, so that's equal to a minus operation. We're adding a negative, so that equals minus. So this is going to evaluate to negative 7. So what we have now is S30 equals 15, 30 divided by 2 is 15, times negative 7, and our answer should equal, I think, negative 105. Okay, next example. Alright, this one's slightly different. We're not finding the sum of the first 20 terms of a series. We're finding the sum of the series between the 4th and the 20th term. So we've got to be a little bit careful. In my video presentation before, I said what the underlying logic really is that you can find the sum of the first 3 terms and subtract your answer from the sum of the first 20 terms. There is in fact an easier way, a more commonsensical way of doing it, and I'll show you how to do that now. But just to note again, we're going to use our formula for an arithmetic series, that one. And really all we need to do is treat the fourth term as the first term in the series. Okay, so our value for A in this case is going to be found by substituting 4 into there. And we're going to treat it as the first term of some different series. Okay, so here we go. A is equal to, substituting 4 into our formula, we get 2 lots of 4 minus 6, so it's 8 minus 6, which equals 2. Okay, so L is equal to, well, we're still dealing with 20 terms, so we substitute 20 into our formula, and we get 2 times 20 minus 6, which is going to equal 34. Okay, so now we can substitute the values for A and L into our formula. But we do have to know how many terms there are in this series. Now it seems to me that the answer is 20 minus 3, because what we're doing is excluding the first 3 terms. So 20, don't go minus 4 to give you 16. What we're doing is excluding the first 3 terms only, so it's excluding 3, 20, take 3 is 17. So N is equal to 17. Let's just note that down. N equals 17. And then we can go ahead and substitute into our formula. Therefore, the sum of the 4th to the 20th terms is equal to 17 on 2 multiplied by brackets. So A is 2 and L is 34. And you're going to find that that's equal to 8.5 times 36, which equals 306, I do believe. Okay, so the sum of the 4th to the 20th terms is equal to 306. Last problem. Didn't mean to do that. Okay, one last problem then. So let's start with our formula as per usual. Whoops, let's put the pen on. Okay, Sn equals n over 2, A plus L. Okay, so our value for n here, now just be a little bit careful. There is 14 terms in the whole series, but we're not interested in the first 3 terms. So what we're going to do is say that n is equal to 14 minus 3, which equals 11. And A is equal to, well, we're going to substitute n equals 4 into our rule. So 8 take 4, 8 take 4 is equal to 4, obviously. So A equals 8 take 4, which equals 4. And L is equal to, well, all we need to do here is substitute 14 into our rule. So L is equal to 8 minus 14, which equals negative 6. Alright, substituting the information into our formula, we get S 4 to 14 is equal to, n is equal to 11, so that's 11 divided by 2, bracket, A we said was 4, and we add negative 6. Okay, so once again we're adding a negative, so that becomes a subtraction operation. So our answer, let's go straight to our answer, S 4 to 14 equals 5.5. This comes to 4 plus negative 6, negative 2, and you're going to find the answer is equal to negative 11. Okay, so there we have it, done.